Welcome viewers. In this video we'll see the cascade connection of transmission parameters, that is ABCD parameters coming under two-port network. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. Transmission parameters, ABCD parameters, that is cascade connection. Two transmission parameters are connected in series. In that case, what is the resultant? What is the advantage of this method? The main use of transmission matrix is in dealing a cascade connection of two-port network as shown below. So the transmission matrix, it is better to go for a cascade connection. Then only we are able to understand if the two networks are connected in series, what is the resultant. So here the two transmission networks are available, NX, NY. XY is stamped as XY. This is the first one, this is the second one, connected in series. Totally it is named as 1 dash. The input of the first transmission network X is 1 dash. And the output side 3 dash. In the between we have 2 dash. While referring the network transmission network X, this is 1, I1 V1 is the input voltage and current of the first transmission network X. Similarly, I2 V2, that refer I2X V2X because of network X. So 1 refer input side, sending end, 2 refers the output side, receiving end. Here I1 V1, here I2X V2X in order to differentiate with the X transmission network. Similarly, in the Y network we have I1Y V1Y. This is the sending end. At the receiving end I2Y V2Y. Right? So 1 refers input side, sending end, 2 refers output side, receiving end. Similarly here also 1 and 2. This X refers X network, Y refers Y network. Now we'll see what is the advantage while connecting this. This is sending end. The output of network X is nothing but input to the network Y. Then the output from the network Y is the final output. Now what is the advantage of this method? So here it is very clear, I2X equal to I1Y. The current from second network is equal to current in the first network is equal to the second network. See the direction both are opposite. Similarly V2Y equal to V1Y. The output voltage from first network is equal to input voltage of the second network. So these two we will use in the analysis. I2X equal to I1Y. V2X equal to V1Y. Now we will see the further detail. Let us consider two-port network NX and NY connected in cascade with the port voltages and currents are indicated in the figure. Right? So what we discussed, two networks are connected in series cascade and voltage and current notations also we verified. The matrix representation of this ABCD parameters. Now we'll see the matrix representation. First we will see the network X. Input voltage is V1, I1, that we already discussed. The ABCD parameter is ABCD because of X network AX, BX, CX and DX. The output is V2X minus I2X. Right? The final output is this one, but this is the output from X network, that is the input to the Y network. So that V2X minus I2X. I already told 1 refers input port, 2 refers output port. In that this X refers X network. Similarly here V1Y, I1Y. This is a Y network. ABCD parameter because of Y network AY, BY, CY, DY. Then the final voltage is V2Y and I2Y. And also we can known as V2I2. It may be taken as V2 because here we will take V1I1. Here also we can take V2I2. That is the final output. V2y is equal to V2 minus I2y equal to I2. Like that also we can take. So it is also observed that at 2 2 dash, that is at the center, we already discussed, V2x equal to V1y. Output voltage of X network equal to input voltage of Y network. Similarly, I2x equal to minus I1y. See, the because of the directions are both are opposite current direction, so they are negative. Current from the X network is equal to output current from the X network equal to input current of the Y network with negative rotation. So we can use this. So we can show that V2x equal to V1y, I2x equal to I1y. So we can combine these two matrices because these two are equal. These voltages, these currents are equal. So we can combine these two matrices. So while combining, what is the resultant matrix? We have V1 I1. This is the input. AX, BX, CX, DX, AY, BY, CY, DY. Both are multiplied. This and this multiplied because these two are equal. And final output is V2 minus I1. I already told. V2Y can be written as V2. I2Y minus I2Y minus I1. So finally it is V1 I1, V2 I2. V1 I2. This is not I1, this is I2. So that is finally we can write V1 I1 equal to AB. This also we can multiply. This is nothing but multiplication of matrix. X network ABCD parameter, Y network ABCD parameter. So for generally we can write ABCD. What is this ABCD? Is the transmission parameter matrix for the overall network. So overall network, the ABCD parameter is this. What is this? This is nothing but product of these two matrices. So what is the conclusion we got from this? This the resultant overall network ABCD parameter is nothing but product of network X ABCD parameter and network Y ABCD parameter. So that is the conclusion we received. So that we'll see that. Thus, the transmission matrix of a cascade of two-port network is product of transmission matrix of individual two-port networks. Right? So while connecting two transmission parameters networks, the resultant is nothing but product of the individual two-port network. So this is the resultant we got. From this property is used in the design of telephone system, microwave network, radar, etc. So while designing this transmission network, we can use this resultant product. While connecting the transmission networks in series in cascade, the resultant is product of individual. That can be used for designing of transmission line, telephone system, microwave system, radar, etc. So in this video we discuss transmission parameters, ABCD parameter while connected in series cascade. What is the resultant? This transmission parameter, this separate video available. This one cascade connection, normal ABCD transmission parameter separate video available. So finally we got, it is the product of the resultant network is the product of individual network. That is the thing we received. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. All the best for your examination.